In this example, we look at deposit and get bank interest again. So a man deposit $5,000 at the beginning of 1 year into a bank, and then at the beginning of each subsequent year, he deposit another 1,000 into the account. So interest is added at the end. So okay, let's try to highlight some of the information given. Okay, so I start with $5,000, then at the end he add another 1,000 beginning of every subsequent year, right? Interest is added to the account at the end of each year at 4% interest, and the amount in the account at the beginning of the 4% is given at the beginning, applied onto the amount that is at the beginning of the year, right? Using a formula for the sum of a GP to find the expression of n for n of n for the value of the amount at the end of each year. So this type of questions, of course, straight away we can just think of end of the year, but it will be easier, especially for a start, to look at both or sequence. Imagine that you are like playing out the entire scenarios, beginning of the year, and as time goes, no, end of the year what happened, beginning of the year what happened, and so on. So you try to run this through your head, and then we try to uh, uh, list it out so that we can see the how the event happens. So beginning of the year, he put in $5,000. So this is the initial $5,000. And end of the year, of course, with 4% interest, you'll be 1 plus 0.4, right? So so don't go in. Students like to write this 1 plus 4 over 100. Okay. Don't do that. Then you end up very complicated. So this is just 1.04. Just use 1.04. Okay. So 5,000 times 1.04. Okay, so at the end of the year, when you go and check the bank account, go and update the bank book, the balance is 5,000 times 1.04. Okay, don't have to work out what's the values because we are not interested in knowing what's the value for now. Okay, so keep it in the raw form. Next, beginning of the year. So this is a carry forward from last year, right? And beginning of the year, he add another $1,000. Then end of the year, what happened? End of the year, it will be the interest 1.04, the 4% interest will be applied to this amount plus the original capital. So it's 1.04 multiplied by this amount. So what is this amount? This amount is the beginning of the year is 5,000 multiplied by 1.04 plus 1,000, right? Okay, so this is what I started with, right? Beginning of the year, and this is the end of the year interest 1.04. Can you see that? Okay, so of course this one can 1.04 and this can be multiplied, you get 1.04 square, and this multiplied in, you get 1,000 times 1.04. So you can see that initially year 1 I have 1 term, year 2 I get 2 term. Okay, year 3 maybe you got 3 term. Then after that we can see some pattern. And this amount will be carried forward to the beginning of next year. So this is the what there is end of year 2, this is the amount of money I have in the bank. And this is a fresh fund. At beginning of the 3rd year, I put in another $1,000. And this whole value, this whole amount will be eligible for the 4% interest at the end of the year. So at the end of the year, what is the amount I will have that? I will have what I started with, which is 5,000 multiplied by 1.04 square plus 1,000 multiplied by 1.04 plus my fresh fund 1,000. Can you see that? So this whole thing that I started with at the beginning of the year is all eligible for the 4% interest. So what I do is whatever here will be multiplying by the principal plus the interest 1.04. And if I were to multiply the 1.04 in, I will end up with 5,000 multiplied by 1.04 cube plus 1,000 times 1.04 square plus 1,000 times 1.04. So you can see that, oh, initially, okay, so so you can see that the sum is made out of 2 parts. One part is the 5,000 multiplied by something, and then you have the another part which is a series, which is 1,000. You see that 1,000 times 1.04 times 1.04 square and so on. So you can see that the sum is made out of 2 parts. So for nth year, how do we generalize it? The first part is the yellow part, which is 5,000 multiplied by 0.04 to the power of something. So because this is based on the this is always there because it's the original sum. So for n month, it will look like 5,000 multiplied by 1.04 to the power of something, right? So to the power of 1, you can see that when in year 1, power 1, year 2, power 2, year 3, power 3, year n, of course, power n. Okay, so this one settled already. Okay, next, we have to settle the blue color. Blue color will be 1,000, right? 1,000 multiplied by what? So you can see that year 2, there is only one term. Year 3, there are two terms. Year 4, there will be three terms. And how the terms look like? It will be 1,000 multiplied by 1.04, 1.04 squared, 1.04 cubed, and so on. So it will be 1.04 to the power of, so okay, so you see, year 2 stop at 1. Year 3 start with 2, then go down to 1. Year 4 start with 3, 2, 1. Year n start with n minus 1, then plus 1,000 of times 1.04 to the power of n minus 2 plus dot 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 until go all the way until where? Go until 1,000 times 1.04 to the power of 1. Okay, 1.04. Okay, can you see that? Okay, so that's how we generalize it. So you can see that again, this one, there's two part, there's a 5,000 part, and then there is this 1,000 multiplied by a different power of 1.04. Okay, so if we were to write it out, value of his account, money in his account at the end of the nth year will be this sum, right? 5,000 times 1.04 to the n. So this is the yellow color part, and then this is the blue color part, right? Okay, so this one is easy, is better for us to rewrite it, right? Rewrite it in reverse form, reverse order. Okay, so it's all the way until this one, okay, until n minus 1. Oh, okay, now so then we can simplify this. So you can see that the yellow color part is actually there's nothing much we can do about it. So this one will be just equals to 5,000 multiplied by 1.04 to the power of n. But you look at this blue color part now, it's actually a sum of GP, right? Oh, this blue color part is actually, you can look at it, is 1,000. Then you have 1.04 plus 1.04 squared plus 1.04 cube plus until where? Until 1.04 to the power of n minus 1. Okay, so what is this? This one is a GP. The first term is 1.04. The common ratio is 1.04. And what is the number of term? Number of term will be, you start from 1, of course, the number of term will be n minus 1. So we apply the sum of GP formula. What's the sum of GP formula? S of n equals to A multiplied by, so in this case, the R is more than 1. So I use R to the power of n minus 1. Okay lah, we use 1 minus R to the n also. Okay, never mind. 1 minus R to the n divided by 1 minus R. Okay, so this, the second part will be plus, this is 1,000 multiplied by A, which is 1.04, multiplied by 1 minus R, 1.04 to the power of, this is number of terms. Number of terms is n minus 1, so it's n minus 1. So do not be confused. Okay, divide by 1 minus 1.04. Okay, so once we have that, we can just simplify. Okay, so the this part no change, this part no change. So this part we can simplify. Okay, so this is negative 0.04, and when you divide, you get 26,000. Negative 26,000 multiplied by 1 minus 1.04 to the power of n minus 1. And of course, we can flip this around and make this positive. And after that, we can just factorize in. Okay, so this one or this one you can expand. This one we can simplify lah. This one can simplify. So this one will give you 5,000 5,000 and 5,000 times 1.04. Okay, so this is 5,200. This 5,200. Then minus 2,600. 26,000. Right? And plus 26,000. So you get 31,200. Okay. Then this one you multiply in, you get minus 2,600. Okay, so this one, yeah, this is the so what the question asked for? The question asked for an expression, right, for the amount at the end of n years. So this is the expression that the questions asked for. Okay.